Hello everyone, I welcome you all for the video lecture on Python. Today, let us discuss illustrative programs, the foundation of functional software. In this presentation, we will explore the fundamental programming concepts. We will bridge theoretical knowledge with real-world applications. We will understand the building blocks of robust software systems. So, what are illustrative programs? They are the simple, focused logic. They demonstrate core programming principles. They solve the problem using algorithm design and data handling. The fundamental operations showcase counting, input output, and validation. Let us take a program and analyze it. In program 1, we have word count. The function, what it does is, it will count the word in a text string. The algorithm splits text by white space, then counts segments. The applications are, it is used in text editors, CMS platforms, SEO tools. The impact is it automates counting 1000 words in less than 0.01 seconds. Let us discuss another program, copying file. The core function is it replicates content from source to destination files. The underlying algorithm reads data in chunks, handle error conditions. The practical applications are it is used for data backups, software installations, system migrations. The efficiency impact. It copies 10 gigabytes in minutes, reducing human error by 99%. Another program, voters age validation. The purpose, it verifies if age meets legal voting requirement. The method, it compares input age against a minimum threshold. Use cases are online voter registration, civic engagement applications, and government databases. Program 4, ranging mark from 0 to 100. The core function is it ensures numeric input is within the range 0 to 100, and then the algorithm checks if input is greater than or equal to minimum value and less than or equal to maximum value. The applications are student grading systems, survey data entry, and QC systems. The core principles illustrated here, the input validation. It always ensures data integrity and security. And then comes to the modularity. It breaks problems into reusable functions. It also does the error handling. It manages unexpected situations gracefully. Control flow, coming to the control flow, it directs program execution with conditions and loops. Real world applications and impact. Coming to the efficiency, it automates tasks and saves time. Accuracy validates and minimizes errors. Security, first line of defense against vulnerabilities. Best practices in development. Clear requirements define scope and expected behavior precisely. Thorough testing. It implements unit test for each function. User-centric experience. It provides intuitive interfaces when helpful. Errors, comprehensive documentation. It writes comments and external guides. Conclusion, the power of fundamental logic. Basic programs showcase universal computation principles. Mastering these builds a strong foundation for complex applications. Continuous learning drives technological innovation. Thank you.